Alright, so first thing we're going to do is get the products. This is CO2 and this is water. The next thing I'm going to do is I'm going to balance the carbons. There's 5 carbons here. That means I need 5 right there. There's 12 hydrogens here. I've got to have 6 times 2 is 12 over there. 5 times 2 is 10 plus another 6 is 16. 8 times 2 is 16. How are we doing? Good? Who got that? Wonderful. Okay, let's take a look at this odd one here, right? Obviously, when you burn this thing, what are you going to get? CO2 and water, right? Main reaction channel, the main thing that's going to happen. 8 carbons here. We're going to have 8 on this side. 18 hydrogens there. 9 times 2 is 18. What is 8 times 2 is 16 plus 9 is what? 25. So you're going to do a 25 halves here. Okay, what are we going to do? Multiply everything by 2. So that's going to be a 2. That's going to be a 25. That's going to be a 16. And 2 times 9 is 18. How does that look? Did we get that one? Yes? Is there anyone that's lost? I got lost? Oh, okay. Okay, the next one here, we're going to get CO2 and water, right? Okay, let's do it the same way. 6 carbons here. You've got to have 6 over here. 12 hydrogens here. 6 times 2 is 12. Okay, now let's count oxygens. On the right-hand side, I have how many? 18, right? 12 comes from here, plus another 6. That's a total of 18, right? Now, how many have I got to have on the left-hand side? 18. All right, but I've already got 6 sitting right there. So what number needs to go here? 6 times 2 is 12, plus another 6 is 18. All right. Oh, stop that. You're sitting back there. Did you get this? Did anybody get this? You got it? So this is what's happening inside of your body, right? You're burning glucose and constantly making CO2 and water. Right? You're breathing out CO2. How do you know you're breathing out water? Well, get in front of a mirror and breathe out on it. You're going to see fog or not? Sure you will. It's a byproduct of metabolism here. Right? You use a lot of water through breathing. All right. Are we ready to move along, or are we still flipped out? Ready to move along? Wonderful. Well, let's do something called a single replacement reaction, or an SRR. Okay. This is reaction class number 2. Remember I told you there's 5. So, a single replacement reaction, let me give a couple. Aluminum plus HCl. I don't want to do it, or not just yet. Magnesium plus HCl. Okay. Calcium plus HCl. And copper plus HCl. And let me put one more up here. Gold plus HCl. Okay. Well, single replacement, that means that one thing will singly be replacing another thing. Okay. So here is what could happen. Is this aluminum could come over here and knock that hydrogen out the way. Okay? Now, if aluminum came over here and knocked this hydrogen out of the way, what would come together? The aluminum and the hydrogen, or the aluminum and the chloride? All right. What is the formula for aluminum chloride? Al. Cl what? 3. How did we know that? Chapter 6, right? Now, what if it was an AlCl2? Would that change things? Yeah, I'd be completely wrong. There is nothing that's AlCl2. It's aluminum chloride. Right? Aluminum has a +3 charge, chlorine has a -1 charge. And this is the thing that sucks about chemistry, right? Just because you learn it in Chapter 6 doesn't mean you can flush it in Chapter 8. All right, well, what's that going to leave alone then? Hydrogen. Does it exist like that? No. How does it exist? Okay, number one thing is you have to get a reasonable chemical expression. Why do I know this is reasonable? Because I know Chapter 6, that's a reasonable compound. AlCl2 ain't reasonable. AlCl4 ain't reasonable. Aluminum has +3 oxidation state. Hydrogen exists as a diatomic. You ready? 2, 2, 6, 3. Is that going to do it for us? Let's check. Don't let this deceive you. Practice these things at home. Number one thing is, I ain't got time to balance them. And let me tell you why students say that. Is because the concept is silly. The concept is kindergarten. I could really teach my 4-year-old, if you put 8 yellow things in that box, there must be 8 yellow things in this box, right? Is there any 4-year-old you know that could not see that? So don't think this is elementary, though. All right? Because, see, watch this. When you change that 2 times 3 is 6, chlorine, what else are you also changing? The aluminum. That means you've got to tinker with things. All right? So just because the concept seems kindergarten-like, in practice it's not that simple. Okay, are we good? So let's recap what's happened. This hydrogen is a plus N, right? And this chlorine's a minus N? Are they married? Yes or no? Yeah. Here comes a boyfriend that's going to kick that hydrogen out the way. Did it work? Yes. All right. Single replacement. This guy has replaced that guy. Look at this one. What's going to happen? Is this guy going to replace that guy? Yeah. Okay. Well, when it does that, what's it going to make? Magnesium what? Chloride. Okay. Sandy says it's going to make us magnesium chloride. Is that the formula for magnesium chloride? No. What is it? Cl what? Well, go ahead. You can get in your periodic table. You don't have to get in your periodic table, right? You don't have a periodic table. Magnesium, everything in that column has a plus what? Okay. Then hydrogen's going to be dangling along by itself, and what's that going to be? H2. So here's what's happening. If I take an aluminum beer can and I drop it in muriatic acid, which is HCl, right? It's brick cleaner, muriatic acid at the hardware store. It will chew up your beer can. Are you with me? Okay. If I take magnesium and I drop that in HCl, it will chew that up. Now, how are we going to balance it? I think that'll do it, right? 1 magnesium here, 1 over there. 2 hydrogens, 2 hydrogens. 2 chlorines, 2 chlorines. Now, what about if I took me some pure calcium? Calcium's right under there with magnesium, right? Okay, will calcium knock this guy out of the way? Yes. And that will leave you a what? Calcium chloride and H2. Put a 2 there. Now what about copper? Will that knock hydrogen out of the way? Well, one would think yes, but it doesn't. It turns out if you put copper inside of hydrochloric acid, it won't do a thing. All right, and I want to bet like this one time in the guard shack, right? I was a lifeguard, we had muriatic acid for the swimming pool, and we were dissolving various things. I ain't playing. And some guy says, well, I got a penny. I bet it'll chew up the penny. And I said, let me see the penny. The penny was from the 60s. I said, it won't, because, see, I knew the pennies in the 60s were copper, unlike the pennies today, which are copper-plated. So we dropped it in there, and guess what happened? Nothing.